Welcome to our second part of the lesson Limits and Continuity. In this video, we'll learn how to find the limit of a function at a given point using substitution method. Find the limit of a function at a given point using factorization method. Find the limit of a function at a given point using simplification method, and find the limit of a function at a given point after multiplying by the conjugate. Before we start, bring your materials and let's begin together. First, recall the limits of a polynomial function and the ratio of two polynomial functions at infinity. Now start with the limit at a given point. Property 1. To find the limit of a given function at a given point, we use direct substitution method. Example. Find each of the limits below. The limit of x minus 2 times x squared plus 5 exponent 7 as x tends to 2 will be equal to 2 minus 2 times 2 squared plus 5 exponent 7, which is 0. As you see, we substitute x by 2 in our expression. Second one, the limit of x minus 1 times x2 plus 1 exponent 5 as x tends to minus 1 will be minus 1 times minus 1 squared plus 1 exponent 5, that is minus 64. C. The limit of sine x times cosine 2x as x tends to pi over 2. If we substitute x by pi over 2 using calculator, we get x equal to sine pi over 2 times cosine pi, which is minus 1. Application 1. Find each of the limits below. Similarly, we substitute x by the given value. So, to find the limit, we should follow the steps below. First, direct substitution. We substitute x by the given value. If we get an answer, we stop here. If we get an indeterminate form, which are infinity over infinity, 0 over 0, plus infinity minus infinity, or 0 times infinity, we first use factorization, then simplification, or multiplying by the conjugate, then simplification. Remember, if a polynomial px has a form ax squared plus bx plus c, it has two distinct roots. Using delta, p of x will be equal a x minus 1, x minus x1, x minus x2. Also remember, the conjugate of a plus b is a minus b. Examples. Needed to find the limit of 5x over x2 plus 2x as x tends to 0. If we direct substitute x by 0, we'll get 0 over 0, that is indefinite form. So here we use factorization. We take common x in the denominator, we simplify by x in the numerator, and we'll get 5 over 2. Here we use factorize, then simplify. Another example. To find this limit as x tends to 1, if we use direct substitution, we'll get 0 over 0. We use factorization by delta, we get the factorized forms, and then we simplify by the common factor x minus 1 to get our limit. Part C. If we substitute here x by 8, we'll get 0 over 0 indeterminate. So we multiply by the conjugate. The conjugate of radical x plus 1 minus 3 is radical x plus 1 plus 3. But if we multiply by this conjugate in the numerator, we should also multiply by it in our denominator. We multiply by this conjugate and simplify to get our limit. Please bring your paper, write the summary of the rules given, and start do our application. Here, this limit has two possible values. In your opinion, which is true and which is false? Farah or Fatima? Go back to the beginning of the video to know the correct answer. Now, do this application alone. As a summary about limits, from the first and second parts, this is your assignment. Please do it very well. If you miss some details, watch again the video and then do it, please. Assalamu alaikum.